The return to the moon does not begin with a launch. It begins with a steel tower crawling back into a building at less than walking speed. On April 17, 2026, after a 6.4-kilometer trip across Kennedy, Space Center Mobile Launcher 1 rolled into the vehicle assembly building again. Not as a victory lap, as a warning. Because 2 weeks after Artemis II sent 4 astronauts safely around the moon, NASA was already back on the ground inspecting damage, washing away corrosive residue, and preparing the same giant structure for something even harder. That is the part most people miss. Going back to the moon is not a single spectacular moment. It is not one rocket, one crew, one flag, one landing. Apollo made it look like a burst of courage. Artemis is exposing what it really takes: infrastructure, repetition, repair, and systems that survive contact with reality. And reality is harsh. This launcher stands about 116 meters tall. It weighs more than 5 million kilograms. It exists to do one thing with absolute precision: hold a vehicle so violent, so mechanically unforgiving, that even a successful mission leaves scars behind. If America wants a permanent path back to the moon, then this machine matters almost as much as the astronauts. Because Artemis III is no longer just about reaching the lunar surface. Now, the mission is becoming something more cautious, and in a way more revealing. A test, a restructuring, a quiet admission that sustainable lunar return is harder than the public story allows. And that raises the real question. If the most powerful space program on Earth has to slow down, redesign the mission, rely on a mobile launch tower from Florida, and wait for a giant lunar lander from SpaceX to prove itself first, then, what does returning to the moon sustainably actually mean? And how far away is that future really? Most people still picture a moon mission the way they picture Apollo. A giant rocket lifts off. A crew disappears into black space. A few days later, human boots touch lunar dust. It feels direct, clean, heroic. But Artemis is not built around that illusion. What NASA is trying to build now is not a stunt. It is a supply chain. And supply chains are slow, fragile, and brutally exposed to every weak point in the system. The launcher has to survive launch loads. The rocket has to be stacked on time. Orion has to be checked, refurbished, and certified again. Ground crews have to repair what the last mission damaged. Even success creates more work. That is why the movement of Mobile Launcher 1 matters so much. This was not just a giant structure being parked indoors. It was the reset of the entire machine. The crawler transporter moved it at roughly 1 to 2 kilometers per hour, with positioning accuracy measured in fractions of an inch. A vehicle from the Apollo era was carrying a launch platform for a moon program that is supposed to define the future. That contrast tells you everything. Space exploration does not progress in a straight line. It advances by stacking new ambitions on top of old hardware, old constraints, and old failure modes. And the launcher itself is not passive support equipment. It carries the umbilicals that feed the rocket power data, cooling, and propellant before launch. It supports access, arms elevators, flame hole protection, and the ground systems that make SLS and Orion operable at all. When the rocket leaves, the launcher stays behind and absorbs the punishment. Then, technicians walk back into the residue and start again. This is the hidden cost of going back to the moon. Not just building a rocket powerful enough to leave Earth, but building an entire architecture that can be used again without breaking the program every time it flies. And this is only the ground side of the problem. The first major wall is not the moon. It is what launch does to the machinery that stays behind. When Mobile Launcher 1 returned from Pad 39B, it was carrying the aftermath of Artemis II. Not failure. Something more inconvenient than that. Success with damage. The kind of damage every future mission has to absorb if this program is supposed to become routine. Solid rocket boosters do not leave quietly. They flood the pad and the launcher with heat, pressure, vibration, exhaust, and corrosive residue. Even when the system performs as designed, the structure still has to be inspected piece by piece. Umbilicals have to be checked. Elevator systems have to be repaired. Flame hole panels have to be cleaned and evaluated. Teams in protective gear move through the tower because the chemistry left behind is as real as the engineering. That is what sustainable exploration looks like up close. Not astronauts floating over the moon, but technicians power washing steel after a launch because residue from one mission can compromise the next. And timing makes it worse. NASA's current flow leaves very little room for fantasy. The launcher has to be turned around. Booster stacking is expected to begin in August 2026. The SLS core stage is expected to follow in October. Once that process begins, this tower is no longer just a structure. It becomes the center of a countdown that stretches across hardware crews, contractors, and months of schedule risk. This is also why the delay of Mobile Launcher 2 matters more than it sounds. In public, a delayed launcher sounds like paperwork. In reality, it means NASA is still leaning on the same platform, the same tower, the same essential hardware path to keep Artemis moving. There is less redundancy, less flexibility, less margin for surprise, and space programs fail in the margins. Because the hardest part of a lunar mission is not usually the part people notice. It is the chain of ground systems that must work almost perfectly before the rocket ever moves an inch. And once you see that the mission starts to look different, not simpler, not closer, just more honest. The deeper system now runs straight through SpaceX. NASA's current Artemis III plan is a low Earth orbit demonstration in 2027 where Orion will test rendezvous and docking with one or both commercial landers. That sounds like a smaller mission. It is not. It is NASA admitting that the lander is no longer a side vehicle at the edge of the architecture. It is one of the architecture's most dangerous moving parts. Starship HLS is enormous by lunar standards. NASA describes it as about 50 meters tall, roughly a 15-story building, with an elevator carrying crew and cargo between the cabin and the surface. That scale is part of the promise: a larger habitable volume, more cargo, a path toward reuse, not an Apollo-style vehicle built to do one fragile job once, but a system meant to turn the moon from a destination into infrastructure. But that promise sits on top of the hardest engineering in the whole chain. Before Starship HLS can support actual lunar landings, SpaceX still has to prove long-duration operations in orbit, vehicle-to-vehicle cryogenic propellant transfer, and a design stable enough to pass critical design review. NASA's own 2025 HLS update said SpaceX was working towards CDR in 2026 and expected to demonstrate large-scale cryogenic propellant transfer and long-duration on-orbit testing in 2026. The NASA Inspector General warned that cryogenic fluid management remains one of the most significant technical challenges in the program, and that delays, tied to Starship version 3, were already pressuring schedule assumptions. And this changes everything. Because once Artemis depends on orbital refueling docking and commercially built lunar landers, the mission stops being a single launch problem. It becomes a choreography problem. Multiple vehicles, multiple providers, multiple reviews, multiple opportunities for one small failure to push an entire year off the calendar. Reuters reported that NASA is now pressing both SpaceX and Blue Origin to accelerate development while officials openly point to in-space refueling and final descent capability as major remaining risks. This is why SpaceX matters so much to the idea of a sustainable moon return. Not because Starship makes the mission easier, because it is one of the few systems ambitious enough to make sustained lunar operations even conceivable. Blue Origin's Blue Moon gives NASA redundancy and a more traditional competitor. But Starship is the vehicle carrying the larger bet that scale reusability and repeated flights can eventually beat the old logic of exploration, where every mission is so expensive and so rare that permanence never begins. This is why Artemis matters beyond the launch pad. A sustainable return to the moon is not really about revisiting Apollo. It is about building a transportation system that can keep working after the headlines fade. NASA now openly describes Artemis as the foundation for a sustained lunar presence, with Gateway supporting missions in lunar orbit, commercial landers carrying crews down to the surface, and later architectures moving toward more frequent, more affordable flights instead of rare national spectacles. In March 2026, NASA said that after Artemis V, it wants increasingly reusable, commercially procured systems, initially targeting crewed lunar landings every 6 months. That changes the meaning of the moon. The lunar South Pole is not just a dramatic destination. It is where permanently shadowed regions may hold water ice, one of the most strategically important resources off Earth. Water means life support, oxygen shielding, and eventually fuel. It turns the moon from a dead endpoint into a logistics node. And once that becomes real, every docking test, every launcher, refurbishment, every delayed review stops looking like bureaucracy and starts looking like the price of building an industrial foothold in a place that was never meant to forgive mistakes. But the risk is still everywhere. NASA's own Inspector General says cryogenic propellant transfer remains one of the most significant challenges for the Human Landing System program. Reuters reports NASA is still pressing SpaceX and Blue Origin to accelerate lander development while watching final descent docking and refueling milestones closely. Even Orion, after a successful Artemis II flight, returned with only minor heat shield char loss, rather than perfection, a reminder that deep space systems do not become routine just because they work once. And there is a larger pressure building around all of this. China is still aiming for a crewed lunar landing by 2030. That means Artemis is no longer just a scientific program or an engineering campaign. It is also a race against delay, against cost, against institutional fragility, and against the simple fact that space rewards whoever can build cadence, not just capability. The country that returns to the moon and stays there will not be the one with the best speech. It will be the one that learns how to make extreme complexity repeatable. So, this is where the image of the moon changes. Not a place you visit once to prove you can, but a place that slowly forces you to become honest. Honest about mass, honest about damage, honest about schedules, contracts, propellant, and the fact that one successful mission does not create a system. It only reveals what the system still cannot do. NASA's Mobile Launcher 1 returned to the Vehicle Assembly Building on April 17, 2026, specifically to begin the next cycle of inspection and preparation for Artemis III. That is the real meaning of sustainable return. Artemis III is now planned as a 2027 demonstration in Earth orbit, testing rendezvous and docking with commercial lunar landers before anyone tries to descend to the surface. Artemis IV, targeted for early 2028, is now the mission meant to carry that landing forward. On paper, that sounds like delay. In reality, it is something more serious than delay. It is a recognition that the moon does not care about ambition, only preparation. And maybe that is why this moment matters. Because the future of lunar exploration will not be decided by one launch, or one speech, or one spectacular landing. It will be decided by whether this vast machine can become repeatable. Whether rockets can be turned around, landers can be trusted, and all the hidden ground systems can survive long enough to make the next mission feel less impossible than the last. Reuters reported that NASA's reshaped Artemis sequence is now explicitly built around that test-first logic. The moon is still there, silent as ever. What changes now is whether humanity can build something durable enough to keep going back.